Last time I sent you some notes based on power and efficiency, and many of you have stated that it was difficult to understand numerical parts. So therefore I am making a clip on numerical only. So this is just to help you understand the numericals better. Now let's go with the first numerical. A man pushes a box to a distance of 5 meters with a force of 100 Newton in 10 seconds. What is the power developed by the man? Now here in this question you are given distance and force, and even the time is given. So these three things are even enough for us to calculate what is the power given. So we have here force of 100 Newton, then distance of 5 meter, and time taken to do this work is 10 seconds. So we can understand that 100 Newton of force displaces the body through 5 meter in 10 seconds. So how much of power is developed? Now we can use the formula of power. P is equal to work done divided by time taken, or we can also simply write it as W over T. So power is equal to W over T, or work done over time. Now let's substitute this value. So power can also be written, well, since work done is equal to force times displacement, we can also write it in this way. So it will be easier for us to substitute the values. Now the value of force is 100 Newton. So we have substituted the force times distance is 5 meter divided by time. So time is 10 seconds. When we calculate 1010 cancels, 5 times 10 is 50. So we have 50 watt. The unit of power is watt or joule per second. So we can write power is equal to 50 watt or joule per second. So this much of power is developed by the man. Now let's go to the second example. The second question says, Pema carried 60 kg rice bag on his head to 4 meter high building in 25 seconds. What is the power of Pema? So in this case, work is done against the gravity. Now 4 meter high building here is a distance which we can replace as a h, height, instead of writing as d. Now the formula that was that we used earlier, like F times d, the formula of work done becomes mgh here. So similarly, then time taken is 25 seconds. Now the given things here, 60 kg. Now he carried the rice of 60 kg. So 60 kg is the mass given here. Then the distance or height is 4 meter. Then the time, value of acceleration due to gravity is 9.8 meter per second square. Now we can also use same formula here. Power is equal to work done over time. But here work done is not F times d, because work is not done across horizontal distance. When work is done in horizontal distance, somebody pushing a box or anything horizontally, we use F times d. But here work is done against the gravity, so we can use mgh over time, because mgh and mgh is also equal to F times d. So power is equal to 60 times 9.8 times 4 divided by 25 seconds. So you may use this calculator. When you use calculator, you will get 2352 divided by 25. So power developed will be 94.08 watt. So you may cross check the answer with your calculator. The next one is efficiency. Now efficiency is to calculate how efficient the person is or how efficient the machine is. If efficiency is in terms of percentage, so 100% efficient machines are highly efficient, then 0% is not efficient at all. Now in case of fraction, if you see, if we have the efficiency value of 1, so 1 is equal to 100% and 0 is equal to less efficient, 0% in case of fraction. suppose you get the efficiency of 0.5, so that means it is 50% efficient. If you get efficiency value of 0.9, so that is 90% efficient. We will be using mostly 0 to 100. We will be using mostly in the calculating efficiency in case of percentage. So we will discuss the formulas firstly. For efficiency, any efficiency is calculated for any machines using work output divided by work input times 100. So here what you have to understand is output is always on the numerator, then input is in the denominator. Then if we are calculating energy, efficiency based on energy output divided by energy input times 100. Now sometimes we have to use movable machines like a pulley and crane. In that case we calculate by using load times distance moved by load divided by effort times distance moved by effort times 100. So these three formulas are used for calculating efficiency of machines. Now let us look at an example each for both type of formulas. So first two formula related to energy and work is almost same only. Then the other one is related to distance, that velocity of machine is a little bit different. We will look at the example each. For the first one, when 550 joule of work is done on the machine, it gives useful output of 420 joule. In this case, work output is 420 joule, work input is 550 joule. So what the question says is, when 550 joule of work is done on the machine, so work done on the machine is called input and work done by the machine is called output. Sometimes it will also be written as work done by the machine, and sometimes useful work or useful output. Now let us apply the formula. Efficiency in percentage is given by work. Now since we are given work here, we will calculate in terms of work. Work output divided by work input. So that is times 100%. So we get, so work output we have is 420 joules divided by 550 times 100. So we can cancel 1 0 and 420 joules. Now in this case, when you calculate, we get when you calculate all together, you will get 76.36%. So efficiency of this machine, which gives 420 joules of output when for 550 joules of input is used, is called is 76.36. So if we say that efficiency, if it is 100%, then we can call that machine as idle machine. But this is not an idle machine because efficiency is just around 76%. In this second example, we have Chimi applies effort of 350 Newton to lift bucket of water from a well using single fixed pulley of 90% efficiency. How much load can Chimi lift from 3 meter deep well? Now what we are given here is effort. Effort is given. We will write given things. Effort, we will just write it as E is 350 Newton. Then in the case of single fixed pulley, so we have a single fixed pulley. Suppose this is a load. When the effort moves 1 meter, load will also move 1 meter. So the distance moved by load and distance moved by effort will be equal. So therefore we can write distance moved by load is equal to distance moved by effort, that is equal to 3 meter in this case. We are not given load, so we have to calculate load. How much load can Chimi lift? So now let's apply the formula. Efficiency. Efficiency is also given as 90%. So we cannot use 90% in calculation. So we have to convert this into 90%. We have to convert into fraction. So 90 over 100, we will get 0.9. So that is the efficiency. Efficiency is equal to load times distance moved by load divided by effort times distance moved by effort. So load is the amount of load that we can carry or lift. Effort is the amount of effort applied to pull the load. Then distance moved by load and effort are the length that the load and effort moves when you calculate when you pull that pulley. So now replacing the value, we get load is not given, we can just keep it as it is. Efficiency, we have got 0.9, and distance moved by load is 3, then effort is 350, and we have got this also, distance moved by effort also 3. These two can be cancelled. Now we have 0.9 times 350. Now this 350 will go up and then multiply with 0.9, because we need only this L, load. So load is equal to 0.9 times 350. So we get load is equal to 315 Newton. So that is our load that Jimmy can lift.